I will be showing you how I calculated individual chlorine concentrations per trial and the average concentrations per building by demonstrating some sample calculations using the raw data collected from the science building. First, I will be demonstrating how to calculate concentration for one trial. We know that 4 drops of sodium thiosulfate were used to titrate the solution in trial 1. The first thing that needs to be done is to calculate the volume of sodium thiosulfate added. To do this, we will need to know the number of drops present in 1 milliliter of solution. This information was gathered and can be seen in this table. To find the volume in 1 drop, divide 1 milliliter solution by the average number of drops that was in 1 milliliter, which was 24. 1 milliliter divided by 24 drops is approximately 0.0415 milliliter per drop. With this information, you can work backwards to find the amount of chlorine that was present in the 50 milliliter sample of water. The equations to do this are shown here. First, because 4 drops were used in trial 1, you can find the volume of sodium thiosulfate added using the value we just calculated. The volume turned out to be 0.166 milliliters. Because we know that the concentration of the sodium thiosulfate solution was 0.025 moles per dm cubed, we can find the moles of sodium thiosulfate used. This turned out to be 4.15 times 10 to the negative 6 moles. With this information, we can work backwards and find the moles of iodine using the ratio of sodium thiosulfate and iodine in the second reaction that took place during titration. With the moles of iodine, you can also work backwards to find the moles of chlorine that had displaced the iodine from the ratio of iodine to chlorine in the first reaction. So after converting the moles of sodium thiosulfate to moles of iodine, and then to moles of chlorine, you can find that there was 2.07 times 10 to the negative 6 moles of chlorine. With the moles of chlorine, you can easily convert to mass using the molar mass of chlorine, Cl2, which is 70.9 grams. I ended up finding that the mass of chlorine present was 1.47 times 10 to the negative 4 grams. This value represents the mass of chlorine present in the 50 milliliter sample of fountain water from trial 1. Since the unit of the term parts per million is milligrams per liter, I had to convert the grams of chlorine to milligrams by multiplying by 1,000 and converting the milliliters of water into liters by dividing by 1,000. To find the milligrams per liter, or parts per million, I divided 1.47 times 10 to the negative 1 milligrams of sodium thiosulfate, chlorine, by 0.05 liters of water to get 2.94 milligrams per liter, or parts per million. I repeated this process for the rest of the trials for the science building and found the individual concentrations, which can be seen here. Next, to find the average concentration of chlorine in the science building, I added up all of the concentration values from each trial shown in the table and divided by the number of trials, which was 5. For the average, I got 3.09 parts per million. However, I went a step further and calculated the uncertainty by subtracting the highest concentration value by the lowest and divided by the number of trials. I calculated an uncertainty of 0.29. So the average concentration of chlorine in the fountain water from the science building was 3.09 parts per million, give or take 0.29 parts per million.